Alright, I've changed my operating system since last time I've made a video, so let's test this new setup by doing a quick start kind of guide on Godot. Godot is a game engine, one which I enjoy using, and it's open source, and you can make your games open source too. It's pretty nice. So this is the version 3.0.6. There's a 3.1 out there which I haven't installed yet, and this is also the mono edition, which allows you to code in C#. But if you are on Windows, you are required to install the mono C# .NET libraries, or whatever it's called. On Linux, if you install Godot through the repositories, it will install that for you, so that's nice. Now, this is the first screen that fires up that shows up when you fire the Godot engine. You can pick a project, or you can create a new one by clicking this button. You pick the title for your game. In my case, I have a hard time thinking about names, because when I start a new project, it is usually just to test ideas and learn the engine, and I don't really have a requirements plan or something like you'd have for a proper game. Let's just use delete me for this one, so I remember to delete it later after doing this demo. So this is the directory where it will end up. Let's create the folder for the game in this directory. Invalid. I think I've picked that one already. Let's do it this way. Alright. Oh, come on. So, deleter. So, okay, this fit. So, now your project files, your game files will be stored in here. Now, by default, Godot will open in a 3D view, which I find it kind of silly, because Godot is better for 2D games, but I guess the 3D capabilities are alright. And after the next version, the 3.1, it is even better. Most of what I'm going to tell about in the 2D view is the same for the 3D view anyway, so let's keep it simple. As you can see, you can change the kinds of views here, and you can also have a script view where you can type code if there's any script available, and an asset library, which you haven't given much use yet. It doesn't have assets for I don't think it has assets for textures or models or characters, mostly just scripts and tools for editing things, whatever. Maybe in the future I might give it use. Now, about the interface. So if you want to start your game to test it out, you press this play button. If it freezes or you forgot to put a quitting button in your game, you have the square button here. If you are just testing a particular scene or particular map, you can press this button. I'm not sure what this does, I don't care. As you can see here, there's info about the C# capabilities, the C# features. You have all these panels and even tabs. This one, the file system, displays you the files of your game, the folders of your game, and the files here. Res will be the root folder of your game. In our case, it's the deleter folder, and there's in this folder there's these files by default. This is for 3D game kind of stuff, doesn't matter. This is just an icon for starters, just to get you started for testing things, I guess. Now, just to not be empty, you can create a new folder, as you can see, whatever folder. As you can see, it goes there. I don't really see much use for this area here. I guess it might get useful useful for if you have favorite bookmarks, but you can also browse folders and directories in here, so I don't care. Now, so where was I? Yeah, you can move your you also have these other panels. The most important ones are the inspector and the scene. We'll go over that later. You can move around things, for example, by clicking the three dots. For example, I prefer the scene tab, the scene panel in this side, as well as the I guess the import can go there too, because the inspector usually is filled with a lot of stuff, and that little space isn't enough to be comfortable for me. You can make those panels hidden, which is useful mainly for scripting, where the texts, so there's more room for text. There you go. What else? So about the game, the workflow itself. So let's go to the important panels. The scene. The Godot works in a very object-oriented way, in a very modular way actually. So everything in Godot is a node in a tree structure. The nodes are like, you can think about each node as a class, which will usually will inherit whatever its parent. So if you have a node A, which is the root of another node B might depends on the circumstances, but will inherit attributes or behaviors from node A. So whenever you have a node, every game object will be a node. Whenever you have a node selected, the inspector will allow you to see its properties and attributes. This panel here is something a little bit more advanced, where when you want to connect signals, like there's a messaging system between objects. I won't go over that today. Now, about the nodes. For example, our game doesn't have levels, nor maps, nor characters. Let's try to make just a simple map. For that, so let's say this opened scene, which is just empty, it isn't saved yet, is our first level. Let's add a starting node, a root node. Here's a long list of nodes, each one with different behaviors. You can check the documentation for that. Usually there's a plain boring node which doesn't do much. You can attach scripts to it, and there's a special node if your game is 3D, control node for user interface UI elements, and node 2D for 2D games. It doesn't really matter what you pick. No matter what kind of game I'm doing, I usually start with I make maps with plain old node, but you might want to make it explicit, the map to be a 2D game, so you can use this one. Let's do this. So as you can see, the inspector has its properties. The 2D nodes don't really have much to say about, because it's 2D. It will allow you to change its position and rotation and scale, but these attributes are kind of meaningless because the 2D node doesn't have visual representation. If you try to run the game, it doesn't do much. So we'll have to inherit other node which does have visual content. That would be the sprite, for example. As you can see, we can type on the search bar if we find it hard to browse through the Halden nodes in the list. Yeah, that's right. We don't have we haven't chosen a texture yet for the sprite, so it isn't doing much. As you can see, you can pick it here. There's different kinds of resources from where to take the texture. You can have an atlas. If you are familiar with other kinds of game making engines, this might sound familiar. One way to pick a texture, you might just load it, or if you don't want one of these special resources, or if you don't want to create one, that is, or you can just drag the file here, right here, as you can see. That works too. You might want to also drag the file into the viewport, and that will create a sprite for you automatically, as you can see. Now we have two sprites. We didn't have to choose a node for it. So now, where am I? So now let's try to save this level. Let's press Ctrl S. We pick a folder for it and the name for it, or level, for example. And one thing to note in Godot is that the editor doesn't distinguish, the engine itself doesn't make a distinction between the kinds of objects. We've defined this as we decided this is a map, but it could be a character too. Characters and maps and whatever aren't distinguished by types of resources, let's say. They all are considered nodes in a tree structure, and they can inherit each other. For example, let's try to do a character now. Usually for characters, you'll want to use a kinematic body, 2D in our case, because it has some physics properties. It will be able to compute forces or detect collisions. There are other kinds of physics objects. There are three main kinds. That would be physics. That would be the rigid body, the kinematic we've already mentioned, and the static body. The rigid body has a full-fledged physics simulation, but it isn't really, so it will fall for gravity, move by itself, but it isn't very good for for characters, because characters are usually kinds of game objects we want to control directly. Static body will impart physics behavior on other objects. So for example, a rigid body object will bounce on it, but on itself it doesn't do much. It stays in the same place. So because we are going to make a character, we'll pick the kinematic body, obviously. So as you can see in the warning, it requires a collision object, because by itself it doesn't really have collision behaviors. You need to pick a shape for the collision. That will be what's called a hitbox in some literature, let's say. Well, right, so there's two types of collision objects. This one is for complex shapes. We can edit by nodes with like a mesh sort of thing, a web of points, like a vector editing program, but it requires a lot from the computer to render this, to calculate this. So let's just use the primitive collision shape. It lets us pick primitive kinds of shapes. So for example, let's use a circle. So there's a kind of a problem here, because our character doesn't have a visual representation. So let's add one. As you know, you can use a sprite. There's other recent objects we've already picked for convenience. We need to put a texture on it. So here it is. Now, about the collision shape, let's make it bigger. As you can see, it's kind of floaty, let's say. To make it grow from the center, we have Alt. To make it keep the aspect ratio, we press Shift. You can press in combination. and it's kind of annoying that the collision shape is behind the sprite, so we can't really see it. Let's change the order. There it is. In the game, the collision shape won't be displayed. It will remain invisible unless you go to debug and check the visible collision shapes box. It's good to know if things are working as you expect. You can use the middle mouse button to drag, and in 3D you can use the right mouse button to navigate, like if it was a first-person shooter. Let's say you can use the WASD to walk around. So let's save our character. Let's give it a name. Let's call it Mr. Protagonist and save it. As you can see, it will be the Mr. Protagonist scene. You can give it a different name from the node, it doesn't matter, so as long as you remember it. So save. Now, this is the cool part about Godot. We can work on all the components that make up the Mr. Protagonist independent and from anything else in the game. And then we can go to our level and drag Mr. Protagonist into our game. This is not Mr. Protagonist, so let's get rid of it. Oops, actually we've added Mr. Protagonist as a child of the sprite, which was a mistake. Gone. Fixed. Now we have a level with Mr. Protagonist on it. And if you make another level, you can drag Mr. Protagonist into it again. So different levels, the same character, and that's cool. We can recycle a lot of code, let's say, a lot of resources. And as you can see, our character scene was added as a child of the level scene. We can do whatever we want with it. We can put this level scene in another level scene if you want. I don't know why. Maybe there's a good point for it, reasoning for it. So let's check what Mr. Protagonist can do. As you can see, it is a kinematic body because the root node is a kinematic body. Kinematic bodies inherit from the physics body kind of node or class. Nodes are classes if you're really thinking about it. So properties of the collision properties can be found in physics body nodes, but will also be found in everything that inherits physics body, like the kinematic body. So it shows in the inspector too. It will also inherit 2D properties, like stuff that defines position and rotation. You can use this thing to position your character or to rotate it. As you can see, stuff is changed. But note that this is an instance of Mr. Protagonist. The base, how would you call it? Well, the default, that is, the default Mr. Protagonist, as it's defined in its own file, doesn't have these changes. So, if you are familiar with object-oriented programming, this is not anything new to you, but if not, you might as well be aware of that. That makes this kind of system really powerful. You can have multiple characters of the same kind, but they will inherit different characteristics. Let's just not make them children, or they will start inheriting the same attributes. Okay, so as you can see, if this was a monster, for example, you have a upside monster and a upright monster and a sideways monster. Each one will have will be a little different from others, but you only have to code for one of them. Cool, huh? So what else can I tell you about Godot? Let's go check out the project settings. So there's a lot there's a lot of stuff in here that I'm not going to talk about. It's kind of complicated. You'd better just leave stuff alone if you don't know what it does and read the documentation for the rest. One important thing is the input map. So if you there are ways in which you can code the key you can code characters or scenes to act depending on input on keyboard keys and whatever, but the action system is much better because you can just have a generic, an abstract kind of action like walk forward, for example. You put you define a key here, for example W, and if you someday you want to change it, you just have to edit it to up arrow, and in the code stays the same. You don't have to change the code. The code only mentions the forward name. You can have multiple keys for the same action. For example, PC gamers will use the up key, console gamers will use the joy button, I guess. Or there's a lot of choices here. Now, you can have in the same kind of convenient in key bindings, input mappings and stuff. There's also convenient localization options. I never use this. I might one day if I do a project for real. And there's the auto loading, which pertains to scripting. We'll go over that another time. It's kind of it's one of a really cool feature in Godot. It's not really something specific for Godot, but when you are using Godot, you really miss these singletons. This is some other stuff I won't be talking about. So let's go over scripting. For example, we have our Mr. Protagonist. If you want to add some behavior, some coding to it, you have this little script icon with a plus sign, and you can add a script to it. Any node can have a script, and the script will be like a class which inherits the node it is attached to. And so you have to be aware that each node can only hold one script. There's only a single script for each node. So let's go do this for the Mr. Protagonist. Alright, you can pick what language to use on this script. I prefer GD script. It's like a mix of JavaScript and Python. Because I have the mono edition, it will allow me to script in C# too. And if you are an artist kind of person, you can use the visual script, which is like Unreal's blueprints and allows you to code behavior using diagrams. I don't really like it. So we usually don't touch this part. It will it's a good way to throw an error. The template is concerned with, how do I explain this? Well, when you first create a script, Godot will have some default, some boilerplate stuff on it, and you can choose not to have it. The boilerplate stuff isn't really all that useful. It's mainly just to remind you how the scripting works. You can have the default, which is really verbose, has comments and a couple of default methods. No comments is the same, but without all the comments. And empty is for the hardcore people. Let's go for with the default for now. So this is the path where the script will be stored. You can pick another folder. For example, let's store the script in whatever. Alright. Also, if you don't want the script to be a file on its own, you can use the built-in feature which will have the script stored in the scene file itself. So there's a scene file with all the notes and the code as well. I don't really like this because you might want to update the scripts later. Alright, so this is a script for Mr. Protagonist, as I said, with all the comments and boilerplate. So this is the only really important part. You can never delete this. All this is actually optional. So let's get rid of it. Haha. Just kidding. Let me just tell you what it does. So for example, now we have a variable a, which holds the number 2. Simple enough, right? Let's add another variable which holds this string, and this is a special method. Like there are several special methods. This one is also a special method. Ready will run the code after the node is loaded. When the game is running, you load the game object. When that object is loaded, it will print will print this text. Nothing too unusual. The process is part of the main loop. Whenever the game loops around, like you know how games work, there's an infinite loop. So whenever there's a new loop, it will run this code. It will print, for example, another loop, I guess. I'm not feeling too creative today. Delta is the time since the time between the current loop and the last one is stored as delta, and I usually prefer to just have dt. It's shorter. This is useful for physics behavior. So for example, let's say we have a velocity variable. Well, let's just type vel, which is 0 to start off, and a force variable where thrust equals 100. So every time the game loops, velocity might be thrust times dt. So this will be in accordance to actual physics, quick maths. So what else? Yeah, now process this magic method process isn't very good for physics stuff actually, because it will try to loop as fast as it can. So depending on the performance of your game, the behavior will change, and that isn't good. For example, if you have a character which moves according to physics rules, it will start to move faster in faster computers, move slower if a computer slows down. That isn't very desirable. To keep the character movement synchronized with real world timings, we use physics process, which works pretty much the same, but it will try to keep dt delta constant, or at least keep it meaningful to synchronize with real world time. So what else? I think this is most of it. Pass will just so you can put in placeholder functions without having any code to run, so it doesn't throw an error for having an empty function. You can have your own functions, of course, func, my stuff, my method, or whatever. Yeah, you can have arguments, nothing unusual, just yet another programming language. Print stuff. print B, for example, whatever. Here's another cool thing. If you have a level designer in your project team, which you don't want to have to mess up with the coding, or for example, he doesn't understand coding at all, he don't. The level designer will refuse to work on the level if he has to change variables. You can just export a variable. And what this will do, let's check. So if you go back to the 2D view, oops, not that, you can press on the node, and as you can see, it has a thrust variable here now, so your level designer can just put things around in the editor without messing with code. And if there is some variation with this Mr. Protagonist in relation to other Mr. Protagonists, you can just type in the code. You can just type in the numbers, I mean, and the programmer will deal with the code behind that makes meaning out of that number. As you can see, this Mr. Protagonist can have 100, but this one can have 999, oops, and this one can have like 42 or whatever, and they will all have different behaviors according to that, without having to deal with the code directly. So yeah, that's cool. So as you see, every script will have a node attached, but you can go to project settings. Actually, let's just do something first. Let's go to the script editor. We can have a new file which isn't attached to any node. It still has to inherit something. If you just use the plain old node, plain boring node, it's okay, doesn't matter. Let's give it a name. Let's type in the top. This is the top script. It isn't attached to any node. And now we can go to the project settings and auto load. We can pick a file or top script. We can give it whatever name we want. Doesn't have to be the same name as the file. And this is really cool because this script will now be accessible throughout the whole game, no matter what level in the tree structure or whatever scene you are in. So you can have for example, you can have a var foo, which is equal to something, I guess. And now we can go to the protagonist script and we can print top dot, and the autocomplete will help you probably. Top, what do you call it? Foo. As you can see, there's foo in the autocomplete, so it will now print the 42 when this node is loaded. That's really useful. Now what's next? Can have how many singletons as you want, just make sure they make sense. I think I'll leave my Godot tutorial here for today. Thanks for watching. Don't forget to donate and subscribe to PewDiePie, I guess.